This video is to review sequences and series. So I have a few sequences here. At least go through and see if you can name them arithmetic, geometric, or neither. So pause the video and see if you can do that part. So number one, the change here is +1, but then here it's +2, and then here it's +3. So it's not adding or multiplying by the same thing, so this is neither. Number two, add 3, add 3, add 3. So you are adding the same amount each time. So D is 3. Remember that our formula, AN, is A1 plus N minus 1 times D. So AN is going to be the first term, -1, plus D, we know is 3. I could put that 3 in front, times N minus 1. Distribute. AN is going to equal 3N minus 4. Also, remember, you could always make this a table. This is the first term. If I want the 0 term, I would have to -3 in that direction, and that's where that -4 came from. Remember, this is the explicit form. If we want the recursive form, we will take A sub n, and it'll be based on the previous term. So based on AN minus 1, what do you do every time? Well, you add 3. That says you take the previous term and add 3. I should probably say A1 is equal to -1, so we have the entire thing. So if I know the first term, I take the previous term and add 3. Okay, number 3. This is times 2 times 2 times 2. So you are multiplying by the same thing each time. So that multiplier is going to be 2. Remember, our formula is A1. We might call it R in class. We might call it M. Doesn't really matter. Times R to the N minus 1. So AN is going to be, our first term is 1/4. We figured out R is 2, and it's always raised to the N minus 1. Again, that's the explicit formula. If I wanted the recursive, I know A1 is 1/4. And for every term, you're going to take the previous term. Previous has a subscript A, the subscript is M minus 1. And then you're going to multiply it by 2. So maybe a better way to write this would be 2 times AN minus 1. That's our recursive. Okay, sequences. Say we have an arithmetic sequence where the second term is 2 and the fifth term is -7. So sometimes it's helpful to make a table. Maybe you don't want to, that's fine. I find it helpful. So we have AN and N. We know the second term, when N equals 2, I'm going to put that here, is 2. And then 3, 4, fifth term is 7. So we can find the slope, D, or difference, or M if you want to call it slope, if we take the y's, 2, and we subtract them, -7, so minus -7, and then we take the n's in the same order, so second term minus fifth term. That's going to give me 9 over -3, so it tells me D is -3, which makes sense because we went from 2 to -7. Then I also know that, so now that you know -3, you could figure this out. So you could go +3 plus 3 to find that 0 term, or you can use an equation. I know the second term is 2, so 2 equals, I'm going to use B plus -3 times N. Well, but I know N, right? It's the second term, so times 2. So 2 equals B minus 6. Add the 6. B is going to equal 8. So a sub n equals negative 3n plus 8. And probably check and see if that works for the fifth term, right? If I plug in 5, that's negative 15 plus 8 does give me negative 7. I forgot my negative 7 in the table. Sorry about that. So that is my explicit formula for that sequence. So find the slope, subtract the y's, subtract the x's, but they're n's, right? And then use the equation to solve for the y-intercept, the 0 term. A geometric term where the second term is 6 and the fifth term is negative 162. Second term is 6, 3, 4. Fifth term is negative 162. So I have to multiply by r 3 times, right? 6r cubed has to equal negative 162. So divide by 6. R cubed is going to equal negative 27. And then the cube root of that is negative 3. So we know r equals negative 3. And then we know the second term is 6. So 6 equals a times negative 3 to the second term squared. So 6 equals, that's 9a. So a is going to equal, divide by 9. 6 over 9 or 2 over 3. So my explicit formula is 2/3 negative 3 to the n minus 1. Okay, why don't you try to do these? See if you can plug them into the formulas and solve for the sum, right? Sigma means the sum, add them up. Okay, so for arithmetic, right? Number 6 is arithmetic. It's n times a1 plus an all over 2. So make sure you pay attention to sigma. This one's starting at 3. So a1, I'm still going to call it a1, but it's really a3, right? We're plugging in 3, the third term. Negative 9 plus 7 is negative 2. The nth term, in this case, plug in the top, 5. So we're going to 5. Negative 15 plus 7 is negative 8. And then remember, n is 5 minus 3 plus 1. Because count it out. Third term, fourth term, fifth term, that's all actually 3 terms, right? So we're doing 3 times negative 2 plus negative 8, all divided by 2. This is negative 10 divided by 2 first. That's 3 times negative 5. The sum is negative 15 if I did my math right. Feel free to use a calculator. Number 7, geometric because it's got an exponent. Not to infinity, right? Because the top is 9. So our sum is a1 parentheses 1 minus parentheses r to the n parentheses all over parentheses 1 minus r. Again, use I, the index. This time we're plugging in 2. So a1 is going to be 2 times 3 to the 2 minus 1, which is 2 times 3, which is 6. Everything else comes from the formula. So 6 times 1 minus r is the number in parentheses, 3. Oh, I didn't find n. N is 9 minus 2 plus 1, so 8. All over parentheses 1 minus 3. Carefully type it into a calculator. If I typed it in carefully, you should get 19,680 for the sum. Okay, number 8. That one is going to infinity. So we need a over 1 minus r. A1 is going to be 3 times, we're plugging in 1, so it's just to the 0, so it's going to be 3. R is 5/4. Is 5/4 less than 1? No, just because it's a fraction does not mean it's less than 1. This has no sum. That goes to infinity. You cannot get a total adding those up because it gets really, really big really quickly. So don't forget to check r. In number 9, I can see r is 1/3. R is definitely less than 1 for number 9. A1, plugging in the 3, right? 1/3 to the 3 minus 1, or 2 times 1/3 squared, or 2 times 1/9, or 2 ninths. Let me write that over here. 2 over 9. So we have A1 divided by 1 minus, put parentheses around it, R is 1/3. So you could use a calculator or you can do it by hand. I guess I'll do this by hand. I'm going back to the left though, sorry about that. We've got 2 ninths over 1 minus 1/3 is 2/3, which is 2 ninths times 3 halves. You get 1/3 for the answer. Feel free to use a calculator to double check. Okay, moving on to binomial theorem and binomial expansion. We are going to expand this. So, gonna take a lot of paper, try to stay organized. 6 is my exponent, so all of my 6C zeros, they're all gonna start with 6, and you start at 0. That's gonna be times 3 to the x. That gets the 6th power when you start it. And the negative 2y gets the 0 power when you start it. I like to work vertically, so 6c1. The 3x is going to go down 1 exponent, and the negative 2y is going to go up 1 exponent. Notice how many you're choosing matches the second variable. 6c2, 3x goes down 1, negative 2y goes up 1. I'm going to stop talking. All the way until we get to 6c6. 3x has no exponents, and the negative 2y has all 6 exponents. Okay, in a calculator, 6c0, well, that's always going to be 1. Anything c0 is going to be 1. Anything c1 is just going to be itself. Now I'll start using a calculator. It's 15, c3, 20. I'm in the middle now, so I know they're going to repeat. Oops. Okay, then 3 to the 6th, that's a little higher than I have memorized. 729. And the x is to the 6th. 3 to the 5th. 243. And the x is to the 5th. 3 to the 4th, 3 cubed, squared, just to the 1st, and everything to the 0 is just 1. Now the negative 2's, negative 2y to the 0 is just 1, because anything to the 0 is 1. Negative 2y, when you square it, you get positive 4y squared. When you cube it, you get negative 8y cubed. Positive, negative, and positive. Okay, multiply these all together. Remember, you are not adding or subtracting yet. Every line is multiplication. So this is going to say 729x to the 6th, but I need a calculator for the rest. Finish these calculations. Pause your video, finish each row, see what you get. Okay, check yours with mine. Notice they alternate, positive, negative, positive, negative. Also notice the x's exponent is counting down, the y exponent is counting up. And then my final answer, this is going to have to be written really small in order to fit here. It's going to be 729x to the 6th minus 2,916x to the 5th y plus 4,860x to the 4th y squared minus 4,320 x cubed y cubed plus 2,160 x squared y to the 4th minus 576 xy to the 5th plus 64 y to the 6th. Imagine how many area diagrams you would have to do to get this, and how many combining like terms and how many mistakes you can make along the way. Binomial theorem helps us do this much quicker and easier. Okay, last one. Find the sixth term. Okay, so remember, go back here. The sixth term, right? This is my first term, second, third, fourth, fifth, sixth. My sixth term is actually C5, right? So when we do this one, first of all, we're starting with 7 things. So it's going to be 7C. And if I want the sixth term, it's actually 5. And then also remember, those numbers go in these parentheses. The 5 matches the last term's exponent. So this one's going to be to the 5th. And then finally, remember, the 2 exponents have to make 7. So this one must be 2. Then use a calculator. 7C5 is 21. 5 squared is 25, x squared. And then 5th power is negative, and y to the 5th. Multiply 21 times 25. Don't forget there's a negative, so negative 525 x squared y to the 5th would be the sixth term if I expanded that whole binomial. Okay, that's it. Yes. Hope this helps you guys, and I hope you're doing well.